have off between things, you know?
So I want to ask, if you get to vacation, I want to ask about going from being a comedian
need to have the rigid body active, otherwise the script that we apply to this cube won't work. So I'm just going to quickly get rid of the mesh. So to roughly round about there. So I'm going to set this as some whole numbers for now. 102. Over here somewhere, so 486 and 1, maybe 40, somewhere there. So I'm going to zoom out a little bit and we'll have it roughly this area here. I want to increase the size of the trigger zone just in case if we need to. So let's start by bringing it to probably about there, so 488. And this here to about 144. So this area around here is what we're going to trigger. Let's rename this to skeleton trigger. And finally, before we actually start coding, let's add a rigid body to our skeleton. So add component, let's go to physics, and then let's go to rigid body, and we also need to tick is kinematic. This will stop the skeleton falling straight through the floor if a collider should suddenly just appear in the center of him, like for example the big cylinder. We need to have the rigid body active, otherwise the script that we apply to this cube won't work. So I'm just going to quickly get rid of the mesh renderer, and then let's create the script. Right click, create, C# script, and we'll call this skeleton wander. And let's open it up in Visual Studio. So the way we're going to do this is we need to have two variables, an X position excuse me, and a Z position. You can do this on the Y as well. Principle's still the same, but I'm just going to keep it 2 for now. So let's get rid of void start, void update, and annotations. We don't need them. Let's start with public int x pos. So we're going to randomize the position for that. Next one, public int z pos. Again, we'll randomize. Now, it's worth noting, so z pos equals random dot range, and in brackets we have 144, and let's have it around here. So we'll say 124 and 144. So 124 is the minimum and 145 as the maximum. So obviously 144 would be the maximum at that point. So that's all good and well. We've generated the positions that we want to have our character in. So what we need to do now is actually say, okay, well, let's place this object there. To do that, we have this dot game object, and it's lowercase g, uppercase O on that one. Remember, case sensitivity is just so important. Dot transform dot position equals new vector 3. Although we're dealing just with 2 here, the X and the Z, we still need to declare it in a 3D environment. So in brackets we have the X position, Y position, Z position. So X pos. Then the Y position currently is 102 for me, so whatever your Y position is, if you're doing the same as me, you would have that. If you're doing a 3 dimension random range, you would have Y pos there. And then finally, Z pos. Semicolon, and save the script. So let's try this out now. When I head back, if you're doing the same as me, you would have that increment. So in brackets we have the X position 2 for me, so whatever your Y currently is 102 for me, so whatever your Y position is, if you're doing the same as me, you would have that. If you're doing a 3 dimension random range, you would have Y pos there. And then finally Z pos. Semicolon, and save the script. So let's try this out now. I'm going to head back to Unity, and I'm going to attach that skeleton wandering script to that skeleton trigger. So drag and drop onto there, and just make sure you definitely have it is trigger right there. And the skeleton enemy, make sure you do have your rigid body attached. And the final thing to do is change that skeleton trigger. So drag and drop onto there, and just make sure you definitely have it is trigger right there. And the skeleton enemy, make sure you do have your rigid body attached. And the final thing to do is change the destination in our navigation AI script to be skeleton trigger. Now I'm going to press play and then head over there with our player, and we should be able to see the skeleton wandering around. Right, so he is attacking. Excellent. Not quite what we wanted. Reason for that, yep, hopefully you guessed it, is because of the cylinder. So what it's saying is basically, excuse me, what I'll do is I'm going to have the skeleton trigger as, so we can see the mesh renderer. I'm going to unplug the scene so we can see it here, and then we'll watch from the sky what actually happens with our skeleton enemy. So we can see he will walk towards it, but he'll start attacking it. Now that is where we have the problem. So what we could theoretically do is, rather than attach the location to the cylinder, we could have that as untagged. We could actually reverse engineer that and have the skeleton trigger tagged as location. And all that means is that for our cylinder now, if we head to our skeleton AI script, what we'll need to do is add in an extra if statement to say, if it's not equal to location, then do what we need to do. So on void on trigger enter in our skeleton AI script, what we need to do is add in if, and in brackets, other dot tag not equal to, which is the exclamation mark and equals. So if other dot tag not equal to location, then do the following, which is all of the if statement, and save. So what's happening? happening here is we're saying if it's just a random location, then don't interact with it. Carry on as normal. So this should now bypass all of this and carry on walking around. So that's that bit sorted. So I'm going to turn off the mesh renderer, press play, and then let's go and observe our skeleton. Through the forest. There we go. You can see him wandering around already. No problems whatsoever. Just wandering around like a random enemy. So, now let's get into our sequence of events. We want him to come and attack us when we get close. So, if you can imagine, we've picked up our axe, we've spoken to our NPC, and he said go and get the skeleton. So the blockers that we actually have here have now disappeared. So remember when we set those up to say, no, there's, you can't go that way. If we take that block note, duplicate, turn it back on, I'm just going to bring it to about here for now, and I'm going to have that as skeleton activate. So, what's going to happen now, I'm going to remove that block note, is that we need to make our actual script a little bit different in our skeleton enemy with basically the navigation AI script. We need to modify that to give it two possible outcomes, whether it comes for us or whether it wanders around aimlessly. So we need to open up that navigation AI script, and we need to declare two more variables. One of them is a static, and it's going to be a bool, and the other is going to be the player. So public static bool can attack semicolon. Now this basically says, or rather the trigger that we've just created, we'll send a message to this script to say yes we can attack, and we'll basically come for the player at that point. So we'll need public game object the player semicolon. So that does mean that in void update we now have to have an if statement. So if can attack equals true, then do the following, and that's going to be the agent dot set destination, and in the parentheses we say the player dot transform dot position semicolon, and then we say else open close bracket and then the other line of code. So that is how our navigation AI should look now. We've got the two new variables, and then in the update method we say if we can attack, i.e. can we attack the player, is true, then we set the player as the destination. If not, we just carry on following our normal destination. So let's save that script, head back into Unity, and we just need to add, or re-add I should say, the FPS controller to this navigation AI script over here. And then finally, we need to create the skeleton activate script. So that means right click, create, and C# script, skeleton activate. Open up in Visual Studio. And this one is very simple. We just need to have void on trigger enter. Doesn't need to be private, but we can use that other again. So if other dot tag equals player, because remember we tagged our FPS controller as player, then do the following: navigation AI dot can attack equals true, semicolon. Then this dot game object dot get component, open close spiky bracket, and it is box collider, basically because we only want to trigger it the once. Open close bracket dot enabled equals false, semicolon, and save. So let's head back to Unity once again, and skeleton activate script on our skeleton activate object right there, all in place. Save our scene, and now let's press play and put this into practice, and we should be able to see our sequence of events come together in just a moment when I put everything back to normal. Okay, so he's attacking. What's he attacking? Okay, so that was unexpected. Let's have a quick debug of this. Why has he suddenly done that? Did not expect that to happen. Okay, so I'm going to pull the scene out again. Have the skeleton trigger mesh on. Now he will change and come for us, as you can see. There we go. So I do suspect it was because the proximity of our blocker, or rather our activation, and the cube itself, that could possibly be the problem. So what I'm going to do is turn all those objects back on, And move our skeleton activate. In fact, I will turn the mesh on so we can see them visually in the scene. And I'm actually going to move this over here and shrink it on the X quite a bit, so 0.1, just to give ourselves a bit of space. So let's turn the mesh off on all of those. And let's turn our area, block, everything on. And now let's try this entire sequence of events as intended. So we'll save the scene, press play, and let's go. So we want to take the axe and let's go and talk to the NPC. You can see the skeleton wandering around, no problem. And he says, I see you have your axe, I have a small favour. Yeah, let's go do the skeleton. And here he comes. Okay, excellent. Now there's one thing I didn't check there, which I maybe kind of should have done. Turn the mesh render off, because I still want to go to this point where the blocker is. It says we can't go any further, but I just want to make sure that we don't accidentally trigger anything by going that way. So let's have a quick check. So he's still wandering around. Yeah, cannot go that way. So that's okay for now. Everything seems to be in order. The amount of time you'll spend bug testing and just checking everything works in game development is quite extraordinary. It's a very British thing. It's opponent back to have. Okay. So he's just wandering around normally. How very odd. Okay, so let's shrink our scene. Let's have it over here so we can see it. Okay. Now that has confused me. Let's see what's gone wrong there. So our skeleton's doing his normal thing. We're moving. Okay. We're moving. So I can't be too sure what's gone on there, guys. That is very strange. That is very strange indeed. It could be because of our skeleton activation, but however, if we cross this now, he will change and come for us, as you can see. There we go. So I do suspect it was because the proximity of our blocker, or rather our activation, and the cube itself, that could possibly be the problem. So what I'm going to do is turn all those objects back on and move our skeleton activate. In fact, I will turn the mesh on so we can see them visually in the scene. And I'm actually going to move this over here and shrink it on the X quite a bit, so 0.1, just to give ourselves a bit of space. So let's turn the mesh off on all of those. And let's turn our area, block, everything on. And now let's try this entire sequence of events as intended. So we'll save the scene, press play, and let's go. So we want to take the axe and let's go and talk to the NPC. You can see the skeleton wandering around, no problem. And he says, I see you have your axe, I have a small favour. Yeah, let's go do the skeleton. And here he comes. Okay, excellent. Now there's one thing I didn't check there, which I maybe kind of should have done. Turn the mesh render off, because I still want to go to this point where the blocker is. It says we can't go any further, but I just want to make sure that we don't accidentally trigger anything by going that way. So let's have a quick check. So he's still wandering around.
I see you have your axe. Now, I have a small favor to ask. Please, can you eliminate the skeleton threat in the garden?
To pass all of this and carry on walking around. So that's that bit sorted. So I'm going to turn off the mesh renderer. Yeah, normal destination. What's happened? Proximity of mesh off on skeleton trigger now. And let's head over here. He's wandering around, no problem. So we can't go that way. No problems. Let's go and speak to our NPC. Hello. Eliminate the skeleton threat from outside the village. We can do. So now we should be able to go through here. Let him walk away for a minute. But now he's going to turn his attention to us. And down he goes. So this tutorial is done for now. Next tutorial, what we're going to do is carry on from this spot, and we're going to have that sequence go a little further so as we can end this particular sequence. And we might have a gate over there that we can go outside to, and probably have another NP. Hello there, I'm Jimmy Vegas, and this is the ultimate Unity tutorial for right here. Now the NPC himself actually has a collider around him. And I believe this conversation is the trigger. Now, what we need to do is we need to head back into that script, the NPC chat. We need to create another possibility here of, for example, when we have completed the actual skeleton slaying, he says something else yet again. So the idea of what he's going to say, the possibility here of, and I believe this conversation is the trigger. Now, what we need to do is we need to head back into that script, the NPC chat. We need to create another possibility here of, for example, when we have completed the actual skeleton slaying, he says something else yet again. So the idea of what he's going to say is once we've got the skeleton, he's going to give us the key to a gate to get out of this little village. So all we need to say is we need to basically refer to everything else in here as something separate. So for example, when we kill the skeleton, where basically we say that's gone, don't need to do that anymore, we need to say the next thing along. Now, to do that, we need to have that bool as something specific, because at the moment, if we go back here, we have dialog state dot state take ax equals true. So everything we're doing at the moment is done via this dialog state script. Now, what we'll need to do is basically create an internal version of that, but for the skeleton being slayed. So public bool skeleton slayed. By default, we'll make that equal to false, semicolon. What we also have to do now to the current existing if statements is add an and to there. So we need to say if dialog state.takeAx equals false and skeleton slayed equals false, and the exact same little bit of code here as well. So what this is saying now is, because the skeleton won't be slayed at this point, if at any point the skeleton is slayed, so that value becomes true, these two if statements will not work.
バイブレーションでアークを描き、このアースに負けないオブジェを作れ。チゲだ、あファンキーだ、みんな黙って俺についてこい。イエチゲだ、あファンキーだ、みんな必死で俺についてこい。カモンチゲだ、あファンキーだ、みんな黙って俺についてこい。イエチゲだ、あファンキーだ、みんな必死で俺についてこい。カモンチゲだ、あファンキーだ、みんな黙って俺についてこい。イエチゲだ、あファンキーだ、みんな必死で俺についてこい。カモンチゲだ、あファンキーだ、みんな黙って俺についてこい。イエチゲだ、あファンキーだ、みんな必死で俺についてこい。カモン。
Please, come back to me when you have a weapon. I see you have your axe. Now, I have a small favor to ask. Please, can you eliminate the skeleton threat in the garden? Please, can you eliminate the skeleton threat in the garden? Please, come back to me when you have a weapon. Please, come back to me when you have a weapon. I see you have your axe. Now, I have a small favor to ask. Please, can you eliminate the skeleton threat in the garden?
So what we need to do is copy that if statement there, place it below, and then we can remove that, the dialog state take axe, because that doesn't really need to matter at this point. And we say this is now true. So we are saying that if the skeleton has been slayed, i.e. true, then we set the subtitle box on and we make our NPC say something like, "Thank you for your help. Here is the key out of the village." So at that point, all we need to do there is basically say that we need to get the key, village. You know, you got to piece all of this together. Obviously, all of this will remain the same. At this point, because we have is false, so it does actually re-enable it down here. Doesn't say the component is true. Because we only want it to occur once, what we can do is we can add another if statement to this reset chat, so we can't keep talking to our NPC over.
object here. My object. Now, what does plus plus mean, in case you don't know? That's basically like saying we're going to add 1, so plus equal 1 to it. So whatever it equals, we're going to add 1. Plus plus is just the shorthand. So if we're ever just adding 1, use plus plus. Saves you some time and energy. If you wanted to subtract 1, you do minus minus. Kind of the same idea. Okay, so seeing if this works, let's do save all. Make sure your code is all correct. We'll minimize. We come back to Unity. Everything's going to compile. And as always, we want to make sure we don't have any errors. That is not related. Okay. game object called game controller, and we're going to get its game controller. Okay, my play mode tent collectible. All right, we go back to Droid player. Controller. It has a collide test, a move around, and so that there is a trigger on the object, and if we have an object that collides with it named player or tagged as player, it'll destroy it. We can test this out. Good. You know, we're gonna set the Q create that collides with it named player or tagged as player. 6 of each one down is working first. A public bool. I'll call this objects, and changing collected to less than or equal to, just kind of as a catch-all. So if the collectible is less than or equal to 0, then we can say all right, so yeah, let's test that out. Information. So the from it is game controller. There, off of this tag, there's only one in our scene, and you're going to keep it that way. There's only ever one game controller in your scene. So the collectible, once I update that script here, so collectibles, save all. Okay, so what I want to do is I want to add not. So whatever it equals, we're going to. So right now we have it set up so that there is a trigger on the
When I first got into it, same for a lot of types of development as well. Unfortunately, this is not the case for game development. There really are no patterns or techniques that are widely used across the board. The only one that I can think of that even comes close is the Entity Component System pattern, but even that one has a long way to go before it becomes a standard. And that's why I struggled for so long with the problem of how to access variables in another Unity script. I just wanted one technique that I could apply everywhere, but the reality is that there is no standard way of referencing other Unity scripts. Instead, there are a bunch of techniques available to accomplish this goal, and I'm going to share some of them with you now. But first, let's go over a few key concepts. Unity scripts, collaborators, and dependencies. Unity scripts, or just scripts as I'll be referring to them throughout this video, are C# classes that inherit from monobehavior. A lot of the access methods discussed in this video are universal, but some of them are specific to Unity and can only be used by Unity scripts. Collaborators are scripts that require a reference to at least one other script in order to function. They're the most common type of script that you'll write because, let's face it, not many scripts are designed to operate solo. Dependencies are the objects that collaborators need in order to function properly. Without them, your code just fails to run. For the purposes of this video, both collaborators and dependencies are Unity scripts. So, how do collaborators access their dependencies? Or, the more technical way to say it, how do collaborators resolve their dependencies? Well, there are a lot of ways to go about dependency resolution, some that I won't even be covering here because they go beyond the scope of this video. But generally speaking, methods of dependency resolution fall into two categories: external resolution and internal resolution. Each of Each of these categories, with external resolution, responsibility falls are public properties, editor properties, and Unity event methods. Public properties are a no-brainer. You simply expose your dependencies publicly, so some other piece of code can resolve them. Now, this is a great technique because it's so simple and requires no overhead, but be careful when using it because code like this can often lead to bugs that are difficult to track and resolve. A collaborator that's causing a problem is hard to debug if it's not readily apparent where its dependencies are being resolved. Editor properties are like public properties, except they're much safer and, quite frankly, much nicer to use. Unity automatically exposes public serializable fields right in the editor, so you can set them yourself. And best of all, Unity even exposes private variables marked with the serialized field attribute in the same way. Personally, I find this method preferable to just making a field public. Lastly, Unity event methods are functions that are called when specific events occur at runtime. They can be implemented on Unity scripts and used to resolve dependencies whenever those events are triggered. This technique is a little tricky because it's an implicit way of accessing other Unity scripts. For example, the onCollisionEnter event method is fired when two game objects collide. It provides a reference to a collision object that, in turn, has a reference to the other game object in the collision. You can use that game object to search for dependencies using the getComponent method. Next up, internal resolution. The three methods of internal resolution we'll be covering in this video are the findObjectByType method, static instances, and dependency injection. The findObjectByType method searches the scene and returns an active object of the type that you pass it. If there's more than one, it returns the first one it finds. You can also use the plural version, findObjectsByType, if you need a reference to a list of all the matching objects. I wouldn't advise relying too heavily on this method because you don't always know what the state of your scene is going to be when it's called. It can also be pretty slow, so you should avoid using it in your update method as well. Instead, a good use case would be to use it to locate something like a manager script right at startup, something that you know will be active in your scene when it's called. Static instances are scripts that are exposed on a public static property. If you've ever used the singleton pattern, then you should already know what these are. They typically hold a reference to a script that acts as a key to use it to locate something like a manager script right at startup, something that you know will be active in your scene when it's called. Static instances are scripts that are exposed on a public static property. If you've ever used the singleton pattern, then you should already know what these are. They typically hold a reference to a script that acts as a controller, manager, or service for your game code. And as singletons, they generally expose a single instance of a script that's used multiple times in your code. Some developers despise the use of static instances, or singletons, while others swear by them. I tend to use them sparingly, but find them extremely useful in certain situations, but that topic deserves a whole video for itself. Last up is dependency injection. Dependency injection is a pattern for automating dependency resolution. It does this by allowing you to configure all of your dependencies in one place and having them resolved automatically based on that configuration. configuration. While that was made specific, I hope this video
or chest. Also, I will show you how to display the score on the screen. But before, don't forget, let's create the physics material inside. Here I'm using a Text Mesh Pro, but you can use the normal.
Hello everybody and welcome to make a little platform for if I've got it imported, have that to the value all the way up, and we can even make this sort of somewhat shiny and metallic by sliding those values to sort of simple material manipulation, I guess. And we'll just scale this down, and from this we call it corner, and then we to start off with, we'll put, that's a good example, I guess. Okay, so destroys things. I don't know. There you go. That's a good example, I guess. Okay, so this destroy trigger. Not actually collecting anything on well, and UI on the screen for purposes. So we're going to make pixels 10. And then we'll have put this little space in, otherwise your numbers will be like right next to it like that. Need to change the dot points plus plus. Set to 0. So we're going to hit play. I have 5 points. So transform dot rotate.
or Hassan.